In this video, we are going to be solving for the molecular formula of an unknown compound. Now, this problem says that we have a 0.325 gram sample of an unknown vapor that occupies 350 milliliters at 120 degrees Celsius and 730 millimeter mercury. The empirical formula of the compound is C2H3O. So we first need to gather up what we do know. So we have 0.325 grams, and we have 350 milliliters, also known as what would be 0.35 liters. If you want to know how to do that, you just convert using a conversion factor, which would be multiplying this times 10 to the minus 3, or just simply moving this 3 times and leaving you with 0.35 liters. And we have 120 degrees Celsius. Now, since we are going to be using the ideal gas law, PV equals nRT. This is in atmosphere. So we will not be able to use mercury for this, but instead convert mercury, millimeter mercury, to atmosphere. But we do know that 1 atmosphere equals 760 millimeter mercury. So with this information, we can find out how much we have by dividing 730 by 760. Leaving us with 0.96 atmosphere. And we also know that we have 120 degrees Celsius, and as with atmosphere, we have to convert Celsius to Kelvin, and we can do this by adding 273.15 to our Celsius. So 120 Celsius plus 273.15 will give us our total for Kelvin, 393.15 Kelvin. Now that we know what we have to plug in, we can go ahead and do that. But first, we need to know that we are solving for moles, because that is what you need for your molecular formula. Therefore, we can just do some simple algebra and move RT to the other side and solve for N, and that will be what we will be using and plugging into there. So N equals pressure, 0.96 atmosphere, times volume, 0.35 liters, all over our R constant, which, if you don't know, our R constant will be approximately 0.08206, or other times in other equations it could be 8.206, something like that. It could also be 0.08 to, I believe it was 874 or something, but in this case we can just round it to that. and plug in 0.08206, and this will be in liters times atmosphere over moles times Kelvin. And our temperature will be 393.15 Kelvin. Now, once you plug all of that in, you will notice that atmosphere, liters, Kelvin all cancel out, and we are left with the moles of the solution. And once you plug this in, 0.96 times 0.35, the top will leave us with 0.336 over 93.15 over 32.26. And this will leave us with 0.01038 moles. Now, we also know that we have 0.325 grams. So now that we have our moles, we can solve for our moles per grams and divide, our grams per mole, which would be our molar mass, and divide 0.325 grams divided by 0.01038 moles. That will leave us with 31.31 grams per mole of our compound. And we want to know the molecular formula of it, but the molar mass of it, but we know we have C2H3O. So from that, you can either just look up the molar mass of C2H3O, or you can calculate it adding 2 of carbon, 3 of hydrogen, and 1 of oxygen. But I already know it on here, and it is 43.04 grams per mole. So we are going to divide this by this. So 31 divided by 43.04. Well, it leaves us with 0.719. So n is not exactly 1, and it is not really anything we can multiply it by. So this shows us that this would be whatever we would multiply our original by, C2H3O. But since it is not a whole number, we can assume that it is 1. So our molecular formula will not be changing. It will continue to be C2H3O because you multiply it by 1 and it will not change. So that is our molecular formula for this problem.